What's up, guys? This is Ronnie. Welcome back to our channel, Total Technology. So from today, I'm gonna start the machine learning topics. This will be fundamentals of linear algebra. So before going to start the video, I would like to say one thing. I'm just going to start with the mathematical part of the machine learning. Like I will start with linear algebra, then probability and statistics, then calculus, and after that, if anything is required, we'll do it. So probably this is not going to be hardcode coding like our other videos or topics. So initially, 2-3 months, it will be completely on mathematics. So if I start doing some sort of mathematical theory or algorithm only by doing some sort of like PowerPoint presentation and all that, that is not going to help anyone. Because when I started learning these things, I also faced the same difficulties and problems. So what I did, I just I did everything very slowly and gradually. Initially, I just started collecting each and every materials from the internet or from my some of my friends, some of my seniors, some of the like very well-known Twitter accounts, LinkedIn, whatever. Then I prepare some sort of notes, and after that I started with basics of like linear algebra, and from there I gradually I gained some sort of like confidence, and after that it's was like a kind of easy for me. So I will follow the same steps, so it will be easier for all of you to understand, and it will be also help you to save some sort of times. Actually, the thing is that actual learning part for machine learning is probably 3 to if you are doing seriously, it will take only 3 to 4 months just to give you some sort of idea so that you can start learning or start preparing for yourself for deep learning kind of a stuff. But for me it took more than 6 months, because initially I was like going here and there, and there was no concrete material is available. Yes, there is one material available, Coursera from Andrew Ng, that was absolutely brilliant. But again, like there is mathematics, there is algorithm, and there is actual implementation part. So for theory and implementation, that course is absolutely brilliant. It will give you everything like from 0 to 100. But when you are going to tackle some real life problem, you will face some difficulties, because the whatever taught in that course in terms of algorithm or in terms of mathematical things, you will not be able to solve all those problems. So for that you need to again go to Kaggle. So this Kaggle is probably one of the new terms for all of you, but I am sure like most of you are already familiar of this Kaggle. Kaggle is one of the world's largest or probably number one data scientist platform, where all the data scientists contribute globally. So you have to follow those tutorial as well. But don't worry about all those things. I will teach you each and everything from the start. But again, the main part or introduction part, I just wanted to make one thing clear, guys. Just to give you guys some sort of mathematical background or intuition to develop for the future. I'm just bought one kind of digital notebook, so that whatever I can write in the notebook, and it will definitely invisible in the screen. So probably my handwriting and other stuffs are not going to be very much prominent and consistent, because I'll be going to use this laptop or sorry, this tablet for the first time. So please excuse me for that. And the second thing, guys, I'm not an PhD holder, or I haven't done any master degree from a renowned college from any US universities and all. I'm just normal BTech student, and after that I did some sort of 9 to 5 jobs, and after that I gradually gain this sort of interest. So whatever I'm teaching you, probably all these things are from internet, and probably YouTube is my university and Google is my academic institute. So probably I might be wrong some cases. So please feel free to connect with me, because this is one of the serious topic of machine learning, like linear algebra. Probably my concepts are not 100% correct. So probably you guys can definitely help me out on this. But I'll try to do my 100% what can I say, I will try to do my level best, so teach you guys in terms of for your career perspective, so that it can actually help you to land up some sort of job or some sort of freelancing project, and you can confidently tell someone that you are actually uh, having some sort of knowledge on machine learning. So this is the main objective. So guys, lots of talking. Let's start the actual part. So in this part, let me write something. So I'm for first time in YouTube. I'm using this tablet. Like I am actually using this thing for the first time. So this is like going to be like linear algebra. So this is our first part on machine learning. So now the question is that why linear algebra is so important. So before going or moving forward, as I said earlier, linear algebra is a vast subject, and we are going to look at very tiny pieces of linear algebra. And mostly in this particular video, I'm not going to in that much detail of linear algebra. Probably this is going to be half an hour or 45 minutes video. I'm not sure, but in this video actually I will help you guys to understand why linear algebra is important, and what are the context of machine and what context of machine learning is actually related to linear algebra. As I said earlier, in many machine learning algorithms, or in fact most of the machine learning algorithms, the inputs and outputs are actually represented as vectors. Actually, this is not my statement. If you go to any machine learning book from the classical to modern author, everywhere they denoted the input and outputs as a vector. So when someone like talk about input, what is input? Let's say you have to develop one machine in such a way that whenever some sort of liquid is input or liquid or any liquid kind of input is given, it will able to identify that it's a normal water or uh, it's alcohol. So how the machine is going to understand? So form of input will be vector. So the thing is that when you pass some sort of liquid, definitely there could be some sort of like molecular formation, or some sort of like density, or some sort of like color, and some sort of like smell, definitely. So all these things comes together and form one vector. So vector formation for like water and vector formation for alcohol will be different based on those properties. Let's say like color, smell, density, molecular density, or whatever will form one vector. And for alcohol, and the same all these properties, all those four properties could be forming another vector for alcohol. And the machine is having already like this sort of like predefined algorithm defined inside inside their memory. And whenever you pass those things, it will actually what do you say, like unroll all those things in the form of vector, and after that it will able to understand, okay, this is water or this is alcohol. So in that way, like vector is so much important. And when we talk about vector is actually basis of linear algebra. So that is why linear algebra is so important. I know I'm doing very fast and I'm explaining something which is kind of alien for most of you guys, but let me explain you like in a very easier way, then it will be easier to understand. So the main objective is that in machine learning we always deal with numbers. So let me just draw one rough picture over here. Like let's say this is one machine you develop with some sort of algorithm, and then you are giving some sort of input and you are expecting some sort of output. So input is actually number here in the form of number, and output will also will be in form of number. Okay, and after that, depending on some sort of like mechanism or some sort of like unrollment, it is actually able to give you, let's say you input here is given some sort of liquid. Okay, and liquid will be parsed in the form of numbers. So these terms are quite like kind of weird to understand, like how the liquid will be passed in the form of number. But I explain you, the liquid probably having like n number of properties, and this n number of properties could be like density, like color, like many other thing. Like all this could be formed in the form of some vector, and all this thing will be having some sort of numerical values. Okay, so let's say this is water and this is alcohol. All properties will be available as well as for alcohol, and this machine is already having this sort of properties somewhere in the memory. So whenever you pass something, it will go and match with the vector like combination, and it will able to answer that whether this is liquid or whether this liquid is alcohol or kind of water. So this is not like that much simple, like the way I explain you. There will be multiple things, multiple algorithm, multiple other configuration, multiple other things you need to consider. But just to give you kind of like why vector is important and why linear algebra is important, I'm just explaining you. So the main part is that here it is liquid, and here it is actually from the liquid formation we can parse it to or unroll it in the form of vector with some numerical values. So this is the main part. Okay, from vector or from liquid to vector. So let's say if you are thinking about this part is not a liquid, let's say this part is kind of like image, let's say some sort of image. And after that image we have to identify whether this is an image of some cat or some dog. Let's say if it is a picture of some sort of cat, so probably cat's eyes are like this, and after many information will be there. And in case of dog, something's different. So if you unroll this image in the form of with respect to RGB, so image will be unrolled in the form of can be unrolled in the form of like kind of matrix, and from the matrix we can unroll this in the form of vector. And for the dog image also we can unroll in first matrix, and from matrix we can unroll it vector. So let me just clean this picture and it will be easier to understand. Let's say we are having let me explain you one clear example, then it will be easier to understand. Okay, um, I think most important part is, let's say you are having one, let's say you are having one, let's say this is one image like 60 and 60. It's a 60 cross 60 image. Now in this 60 cross 60 image you can think about like this. Let's say this is 60 and the column will be 60, right? Let's say this is 60 and 60. Okay, 60 cross 60 means like in row wise there will be 60 pixel and the column wise there will be 60 pixel. Okay, right? Okay, so the machine learning, the learning tasks that the people usually deal with when it comes to identify this sort of image. So let's say to identify this image, the input here is an image, let's say. Okay, so an output is also going to like identify one sort of like classification, whether this is a dog image or the cat image, let's say. So now the question is that how to represent this image as a vector or a series of number, like as we discussed in the last of diagram what I described. So so the input is usually look like something like this. Now you know the input is image, and even that you are seeing on the screen is actually depending on the resolution of the screen. Let's say this is an image and it is actually what you are actually going to see depending on the resolution, or more specifically the resolution of the screen actually. So this is going to be 60 like 60 cross 60 grid of pixels. So each of these pixel has a single value associated with it, right? And each pixel has a number associated with like let's say these are the pixel. Okay, so each pixel is having one value associated with it, right? And this value is actually one number. Typically this number looks like what you're seeing on your screen is a number of vary between 0 to 25 to 225. Let's say this is like this numbers are actually varies between 0 to 225. Like 0 means like black and 225 means white. If you think about this is as a gray like gray scale, like let's say it's a grayscale, and that number is known as a pixel intensity. So if you consider this image, or if you convert this image in a grayscale, let's say black and white grayscale image, so number will be vary between 0 or 225. 0 means completely black and 225 means completely white. So by giving a value of vector, so you can give this all this 60 cross 60 giving some sort of value. Let's say let me clear this part, then I just explain you the unrollment of this thing. Let's say uh, like 0 1 2 3 like this. So this is now the 60 cross 60 grid is becoming like this, like. So this is what? This is actually one matrix with 60 cross 60. Now if you unroll this matrix, so this is the first column, then the second column will be here, then the third column will be here, and the fourth column will be here. So like this you can create one sort of vector, like, and depending on the vector, now you can easily identify whether this is a cat image or dog image. So if this is a cat image, then it will be fixed kind of classification. If it's a dog image, the vector like numbering will be different, right? This is very like high level thing. This is not like that whether let's say dog is some of the image dog is sitting, some of the image dog is kind of jumping in the some of the images dog is probably sleeping or kind of sideways doing sideways movement or something different. So this is not going to be standard, but you have to develop some sort of algorithm based on this technique only. The main fundamental objective of machine learning is to like parse or unroll the image or like any sort of data in the form of matrix or vector, and so that it will be able to machine can able to quantify. No, so the main objective is to take the qualitative input in the form of quantitative input. So the quality becomes quantity. This is the main fundamental things of linear algebra. So you parse or you have given input in the form of picture, and it will become a vector in the form of vector is for machine learning. Vector is actually the list of numbers. It is not like physicist vector. Like in physics, vector means something with some sort of direction. No, in machine learning it is completely different. Machine learning vector means it's a list of list of something like this is a vector. Like let's say 1 2 3. One could be number of bedroom, two could be like number of garage, three could be number of what's say number of floor. So this is a vector formation of one let's say villa. Like, so we can denote vector in machine learning in any such way. In our case, we denoted the vector like all the pixel intensities. Like the 60 cross 60 image is become 3600 elements. It become a vector of 3600 elements. So the 3600 is actually the dimension of the vector. So now if you think about that, if you are going to plot this vector in like space, then it is actually impossible to plot those things. But again, we can calculate those things in the form of vector addition, multiplication, anything using some sort of standard Python library, and based on that we can actually generate our desired output. So to know those things, you need to have a crystal clear idea about the algorithms and all. So that is why linear algebra. So without vector and vector mathematics or vector operations, or without the knowledge of matrix operation or matrix algebra, whatever you can say, we were not going to deal with this machine learning things. You can just go directly to the machine learning standard libraries like Google is having like TensorFlow. Scikit-learn is from another world most popular machine learning library. You can go through and apply those algorithms directly without having any knowledge. You can do it, but the thing is that if you want to do it by a core from the actual sense of doing machine learning, then you have to know the all aspects of linear algebra and all other aspects of machine mathematics of the machine learning. So and you see vector is the fundamental or basics of fundamental or base of linear algebra, or as well as for machine learning. So that is why I started with machine learning. So image become matrix and matrix become vector. So when it become vector, it was easier for the machine to apply those algorithm. And algorithm, actually you have to develop the algorithm. So development of the algorithm is actually known as machine learning algorithm or machine learning model. So machine learning model or algorithm will be applied on the inputs, and input is actually vector. So to apply those algorithm or to do some sort of operation, you need to have some sort of clear idea, not some sort of, you must have some sort of crystal clear idea and understanding and grasp of the linear algebra, vector math, or matrices, probability, statistics, everything. But in this topic or in this video, I'm just only considering of linear algebra. That is why I'm just talking about vector and matrices. And in other part also we will see why statistics, probability, calculus is important. Okay, so fundamental thing is vector, and vector is or linear algebra or matrix is very much important. So vector and matrix is more or less similar. way we can deal that. Matrix can like unroll in the form of vector. So if you know vector, if you know matrix, then you can in the future videos, like I probably going to use matrix and vector very closely. Don't confuse with that. Vector and matrix more or less similar in the form of like linear algebra machine. Don't get confused with vector with the physicist vector. But in this sort of like our mathematical mathematical topics or mathematical courses, vectors are actually structured or unstructured, like number of unstructured or structured elements. Like let's say you are having like 100 students, so 100 is going to be one element. So you are going to have like 500 department in a school, so 500 is going to be. So let me just explain you this thing. So what are the different vectors in machine learning kind of a thing? Let's say you are having one like college, okay? So in your college you have 5 courses, you have 1,000 students, and you have like 20 classes. So 520 become one vector for your college. So let's say you are having one, let's say you are having one library. Okay, inside the library you will have 600, let's say you are having let's say you are having 600 square feet space. You are having 100 books, you are having 2 AC in the library, and you are having 2 librarian. So this is actually become one vector for your library. So in this way, in mathematics we denote a linear like vector. So it is not like physicist vector, like something is moving in some direction with that velocity. So it is completely different. But again, the operations are almost similar, like vector addition, multiplication, and like all these things. But I'm not going to discuss all these things in this video. I'll be going to I'm only trying to give you some sort of intuition so that you guys can develop your like fundamental mindset why vector is important, because most of the guys are actually wanted me to just directly start the linear regression part or linear algebra, just to skip this linear algebra. Most of them already told me, sir, we would like to we would like to start from linear regression. There is no point of going to start from linear algebra or vector. But no, this is not the right way. I'll do the proper way. I'll start from the linear algebra. Then like in this class I'll be just going to touch base with the vector kind of a thing, and then from the next lesson or the next tutorial I'm going to start with the actual vector operation, like vector addition, vector multiplication, and all, like dot product and all. So another important things I'll just going to explain you. Let's say now the coding part. So as I told you, like when I go through some sort of like tutorial, it's only having either mathematics or only having the code. None of the videos are having, or none of the courses in the internet having coding and the mathematical part together. So for that I'm just creating this sort of tutorial. So I'm here, let me just quickly go through it. So let's say I'm having one sort of image. So this is a football image, okay? So let me open this thing. Okay, okay. So this is one computer vision library for Python. Just forget about everything as of now. So I just read this image, and after that I just um, doing this thing, x dot shape. So see, it is returning kind of like shape. If you guys are familiar with NumPy, so whenever you put something on the NumPy, so this is the like first dimension, this is the second dimension, this is the third dimension. So this means what? Like, let me explain you by opening the image now. Okay, so let me open this image once again. Okay, right. Okay, I'm not sure what is the image. Let me open it again. Okay, okay. So this is a actually colored image. Let's say it is in the form of RGB. Okay, so actually there are three sets of matrix. Why three sets of matrix? In case of grayscale image, as I told you, like each and every like grid will be having like this is actually 432 by 762 grid. Okay, and why this three? Actually, in case of grayscale image, there will be only 432 and 768 like pixel. Now here it is like 432 by 762 matrices, but the number is 3. one for red, one for green, one for red, green, and black. So this is the fundamental thing. Like like each channel is each grid is having three channel pixel intensity, one for red, one for green, and one for black. So 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 there will be three dimensional, so it is going to be three dimensional kind of a thing, like in terms of our normal numpy or matrix thing, this is going to be like three dimensional thing. How many matrices are there? Like three to two dimensional matrix will be there. So the actual dimension will become three. So in the first dimension there will be 432 pixel, then 762 pixel, and in the third dimension it will be going to be like this is number of row, number of column, and then in the last dimension it is going to be the number of matrix. So in this way it is actually become one three-dimensional numpy array. So three-dimensional numpy array means what does it mean? It means like it is having like three two-dimensional array. Like it is dimension is three, and here it denotes three means it will be having like 432 into 766 images three times, like one for R, one for green, and one for blue. So you understand, like, or let me, or you want me to make it a more in a more detail? Well, let me. I can do it. Like this image is actually, let's say, let me open this image again. So actually this image is 2D image, like, and it is having like 432 cross 768 pixels, but then there are three such layers that it has. So it has three such layers. Okay, the three means three such layers, that we have a 432 into 760 cross three images. Basically this is a matrix. So this matrix of a dimension 3, this is a dimension 3 matrix. Understand this thing. The first dimension are like 432 entries, second dimension 763 entries, and the third dimension you have three entries. Like what does it mean? So it is a stack of three images, 600 like 400 cross 760, and just because we have RGB, so there are three images. So you understand correctly. So there are three images with this dimension, so that is why it is 3, and just because the dimension is 3 you can say it a 3 dimension. And if you are having like, let's say, for let's say if you are having kind of like what you say, if you are having some sort of like videos, like video means what is video means? Video means nothing. If you have some sort of video, then the dimension probably would be like this, like 3, okay, and let's say 10. Why? Video is a sequence of images. So image means up to this. Like one image, you can think about this. And as I told you, video is a sequence of images. So in this dimension, the sequence or numbering will be denoted. So this is again very highly classified things. Don't get in that details. If you guys are interested, can do some sort of homework or some sort of assignment how to denote like videos in the form of vector or matrices. But if you can just do a Google or Wikipedia, it will be like this. So if you see, like, more complex things will become more complex in terms of like higher order or higher dimension. So that is why vector is much important, because in the form of vector you don't have to worry about any other things. Only you have to focus on your like vector dimension. You have to think about your vector operation, what operation you are going to perform, and you know the number, it will be always number. There is no other undefined or unclassified like things, kind of normal. Like this is not going to be like what you say, like going to be do some sort of like uh, mm, what do you say, hypothesis related like mathematics, that you are going to prove some a point with some sort of x undefined quantity or y undefined quantity. So everything will be quantified. Okay, in terms of linear algebra and vector, everything is quantified. You have to just deal with numbers. Okay, so when I say number, that could be many other things, but again, for the time being, don't get into that much detail or that much complex. The think about everything will be quantified. So your quality become quantity, and when quantity is applied, you have to apply some sort of logic on your top of your quantity, and that quantity is known as matrix or vector. So that is why vector or algebra or linear algebra or matrix or matrices operation is important. So probably I can stop this video at this moment. I know this is not a very good thing to say, but again, I just give you some sort of give you guys some sort of like idea, like what is vector and why this is important. So let me just quickly go through one sort of like round of whatever we covered in this video. Let me open these things like okay, like let me clear this thing like um, like we covered linear, as I told you, excuse me for my handwriting because I'm just doing with some sort of notebook. So linear algebra, we have seen why this is important, like and after that we have seen like some sort of like vector, why vector is important. When I say vector, it is actually also includes the matrices. So in the next part, in tomorrow's session, it will be like actual operation on vectors. So I will clear the theoretical part, and after that I will do some sort of coding. Okay, so and after that probably linear algebra is going to finish, then I will start probably statistics and probability. In this way we'll gradually like propagating or following or gradually develop our mathematical skill for the machine learning topic. So like once we finish all these topics, then automatically we'll become kind of confident to develop or implement your own like thought process for developing nice and efficient machine learning algorithm. So my objective is to help you or make yourself enabled towards creating like efficient machine learning models, not by copy pasting from Kaggle or not by copy pasting from someone else models or someone else technique, by just applying your own thought process, your own like skills, your own mathematical intuition, your own technical capabilities. So this is my only one objective. I could have done this in a more quick or faster way, just by doing the theories. What is machine learning? This is supervised learning. This is unsupervised learning. Then linear regression. Then uh, uh, what do you say? Then logistic regression, and then some sort of like unsupervised learning with dimension reduction or like kind of other stuff like PCA and all. But no, I'm not going to do that way. I'll be going gradually. The way I learn, I will definitely I will try to share the same sort of experience or same sort of like thought process what currently I'm having with you guys. I might be wrong. I might be some of the time I might be completely talk shit. But again, sorry for the word. But again, please help me with those things. Probably, as I told you, I might be wrong some of the cases in future. So you guys are always there. You can help me or tell me with your clarification or the feedback. So I definitely try to improve. But again, like if you follow along with my techniques and tips, then definitely one day will become good resource on machine learning or deep learning topics, or what like this artificial intelligence or data analytics or data science, because I followed the right path, because there was no like shortcut for me. Like as I told you, I didn't I haven't done any master degree, or I haven't followed any proper course on machine learning. Whatever I learned by like here and there, and all considering all the materials. So I started with vector, I started with linear algebra, I followed or the same like way for my own YouTube courses as well. So that's all guys. So I hope you guys enjoyed the video. I'm not sure, I am doing this thing for the first time, this sort of theoretical training. Probably it is it looks, or it might like be kind of dry for like most of the student, but I'm sorry for that, guys. I'll try to make it more like fun and interactive way from the next time. But don't worry, the content will be actual thing, the content will be there. So I explain you some topics on the why vector is important, why machine learning, and why should we learn vector important. I think I made it clear, but you guys are always there to give me a feedback. So guys, that's all for today. Hope to see you in the next video tomorrow. Till then, take care, goodbye, and also give me your feedback if possible. If you enjoyed the video, please give me your uh, honest feedback, and also you can like our videos by it will actually indirectly or directly support us. And also, if possible, try to subscribe to our channel, hit the bell icon, and ask your friends or family member who are actually interested to learn these things to just have a look on our videos. Okay guys, that's all for today. Hope to see you in the next video tomorrow. Till then, take care, goodbye.